Hey everyone, this is Rubix, and today we are going to show you something that could change how we respond to humanitarian crises around the world. The problem is 122 million people are displaced worldwide, and humanitarian organizations are always 8 months behind. They are reacting to crises, not predicting them. Why is this important? Because if we could predict displacement 4 to 6 months in advance, organizations could pre-position supplies, negotiate access agreements, and save lives. Right now, when conflict erupts in a region like South Sudan or Myanmar, the international response starts from zero. Supplies needs to be ordered, funds raised, logistics planned. But what if we knew the crisis was coming months earlier? That's the problem we are solving, turning humanitarian responses from reactive anticipation. So why use multiple agents instead of one big model? Because this problem requires different types of intelligence working together. Agent 1, Vision Intelligence. These agents analyze satellite imagery to spot early warning signs, refugee camps forming, infrastructure damage, military movements. It uses YOLO V8 for object detection and Gemini Vision for analysis. Agent 2, Displacement Forecasting. Once we have visual data, this agent predicts how many people will be displaced and when. It uses an LSTM neural network trained on historical UNHCR refugee data, conflict events, economic indicators, and climate patterns. Then we have Agent 3, Resource Optimization. Knowing a crisis is coming isn't enough. We need to prepare. This agent calculates exactly what supplies are needed, where they should be positioned, and how much it should cost. Then Agent 4, Crisis Communication. This agent generates alert in multiple languages and distribute them through SMS and email to humanitarian organizations and local authorities. And coordinating all of this is the orchestrator agent. It decides when each agent should run, how they share information, and which workflow pattern to use. Why agent? Because each of these tasks requires specialized knowledge, computer vision, time series prediction, optimization algorithm, natural language generation, and others. One model can't do all of this well. Multiple specialized agents working together can. Let's look at how this all fits together. The architecture has three layers. First is data layer. We ingest data from four sources: UNHCR for historical displacement, ACLED for conflict events, World Bank for economic indicators, and climate databases. That's total 3,899 data points across 31 countries. Then comes to the second layer, intelligence layer. The LSTM model cites here it's trained on 20 engineered features with a validation loss of 1.71 and 85% accuracy. For comparison, our initial synthetic data model had a loss of 51 billion, so real data makes a massive difference. Comes to the LLM backend. We use a hybrid approach. Primary is Google's Gemini 2.0 Flash for fast reasoning and vision analysis. If Gemini fails, maybe we hit API limits. In that case, we automatically fall back to Llama 3 running locally through Ollama. And if that's timeout, we have template responses. This is called graceful degradation. Then comes to the memory system. Three types. Convolutional memory tracks prediction versus actual, so the system learns from mistakes. Episodic memory logs all actions for debugging. And vector memory stores images embeddings for similarity search. The workflow. Satellite image goes to the vision agent, which produces threat scores. Those scores plus historical data go to the forecasting agent for prediction. Predictions goes to sources agent for planning. Everything gets packed by communication agent for distribution. The orchestrator manages this entire pipeline. Alright, let's see the system in action. We are going to run a sequential workflow which processes everything step by step. We can see the orchestrator working, and after the orchestrator, we can see the LSTM model in work. So the output has been generated, and here this states that the prediction 12,000 emergency shelter kits, uh, 890 tons of food supplies, and 15 mobile medical systems. It's even figure out the optimal distribution. 60% is primary sites, 30% is secondary staging areas, and 10% is emergency reserves. And finally, the crisis communication agency is generating situation reports alert. Now let's talk about how this was built. The backend. Flask web framework in Python. We have 8 REST APIs endpoint, status, metrics, agent info, workflow, and 2 for running demos. The demo execution uses server sent events for real-time streaming to the front end. AI agents. 5 Python modules, 1 per agent. Each agent is a class with initialization, execution, and memory management methods. The vision agent loads YOLO V8, waits, and call Gemini's vision API. The forecasting agent loads the trained LSTM model from PyTorch. Then comes to the machine learning. PyTorch for the LSTM network, we trained on 693 rows of UNHCR data, 2,566 conflict events from ACLED, 40 World Bank indicators, and 600 climate data points. The model architecture is 3 LSTM layers with 64, 32, and 16 hidden units respectively. Then comes to the front end. We have used vanilla JavaScript, no framework to keep it lightweight. When you click on workflow, it posts a API demo run, then open on event source connection to API demo stream for live updates. The UI is pure HTML and CSS with CSS grids for layout. We originally used chart.js for visualization but removed it for performance. It was using 15 to 30% CPU. The current statics visualizations are used under 1% CPU. Comes to the deployment. It is optional. Dockerize for portability. We have a Docker file, cloudbuild.yml for Google Cloud Run, and a deploy script. Environment variable handle configuration so API key never goes in code. Comes to the tech stack. Python 3.10 plus with PyTorch for ML, Flask for the web server, Google Gemini API for LLM reasoning, Ollama with Llama 3 for local fallbacks, YOLO V8 for computer vision, real data from UNHCR, ACLED, World Bank, vanilla JavaScript frontend, Docker for deployment. Everything runs smoothly locally or deployed to the cloud in one command. To wrap up, the problem was humanitarian organizations are always 8 months behind refugee crisis. Why we need agents? 5 specialized agent handle vision, forecasting optimization, communication, and coordination, each doing what it does best. What is the architecture? Data layer feeds LSTM model. Agents use hybrid LLMs, backend with Gemini and Llama 3. Memory system enables learning. We have seen the demo. Live execution shows 4 to 6 months advanced prediction with 87% of accuracy. Then the build. Flask plus PyTorch plus Gemini plus Ollama. Deployable via Docker. Production ready with error handling. This is what AI agent can do for humanitarian responses. Turn reactions into anticipation.